Hello, 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 and welcome back to Shiksha DaCosta. Today we are going to be looking at applications of quadratics. So today we're learning how to use quadratic equations to model quadratically related things in real life. And once we have that model, we're going to learn how to use that model to solve a problem in real life. So you're successful when you can solve problems using an appropriate strategy like factoring or like graphing. If you are given the equation of a quadratic relation, including the equations that come from real world problems. To start off, I'd like you to think about, let's get our minds in the right track so we're ready to learn this. What are the three different forms of quadratic relations? Take a minute to see if you can think about these and come up with them. Hopefully you were able to come up with these three. The first one is called factored form, and it looks like this: a times x minus r times x minus s. The second one is vertex form, a times x minus h all squared plus k. And the final one is standard form. And standard form is ax squared plus bx plus c. And this is the one that we already have learned in our previous lessons in this unit, how to factor standard form and how to go from factored or vertex form into standard form. Okay, so we know how to get, maybe I'll draw this. We know how to get from here to here. We know how to get from here to here. We know how to get from here to here. Okay, so we know how to move between these forms. Which of these do you think would be most useful if we are trying to find something like the starting point or the initial value of a quadratic? If you see a word problem or something, if you have a problem in real life where you're looking for the initial value, which of these forms would help you find it the easiest? Hopefully you got a chance to think about that and you arrived at the same answer that I did. It is standard form. Standard form would help us because the starting point or the initial value would be the y-intercept. Remember, the y-intercept is always a value that looks like this: 0, comma, some number, some y value. And if the x value is 0, then standard form would be the best one to find the y-intercept. Because if x is 0, this would be 0 plus 0 plus c. So this number right here is always going to be the y-intercept. Which form do you think would be most useful for finding the maximum? So you can pause this video here again and try to figure out which of these would be the best one if we want to find the maximum. The maximum, remember, is the highest possible y value. And that is actually the y value of the vertex. And remember, the y value of the vertex as a special letter, we give it k. And I see k right here. So if you have a quadratic in vertex form and you want to find the maximum, it's super easy. All you have to do is look at the k value. It's also possible to do that from factored form to get the maximum or minimum, but you have to actually do some work to do it, whereas the vertex form gives it to you right away. Which form would be the most useful, do you think, for finding the value that would result in nothing? So the result to which one would be most useful for finding the x value that would create a y value of 0? Hopefully you were able to figure out which one that is and arrive at the same answer that I got, which is factored form. The x-intercept, that is the value of x that makes y equal 0. What are the x-intercepts? R and s. Super easy to figure that out when you have it in factored form. All you have to do is look at these two numbers. You only do have to remember that this is x minus r. So if you see something like x plus 2, the value of r is negative 2. that is the value that would result in y being equal to 0. So let me just explain that maybe just another way. Hopefully, maybe an example might help us out here. So let me do that. Okay, so let's look at an example here where I have something like 3 times x plus 2 times x plus 3. Well, in this case, if x is equal to one of the, what would the r value here be? Remember, this is x minus r, so this is x minus negative 2. That's what would give us x plus 2. So the value of r here is negative 2. So if x is equal to negative 2, then this would be equal to 3 times negative 2 plus 2 times negative 2 plus 3. Well, that would just be equal to 3 times 0 times 1. And it doesn't matter what these two are. Anything times 0 is equal to 0. So the value r will make this factor equal 0. The value s minus s, would make this factor equal 0. And when we multiply them together, if one of these is 0, the whole thing will equal 0. So factored form is the most useful for finding the x-intercepts. Which form would be most useful for finding the value that would result in the maximum or minimum? So not the maximum or minimum itself, but for finding the x value that would give us the maximum or minimum y value. Take some time to think about that answer, and hopefully you arrive at the answer of vertex form. The optimizing value, in other words, the value that gives you the most optimal, the best number, which would be the maximum or the minimum, depending on which one you want. That number that gives you the best, the maximum, is the x value of the vertex. And remember, the vertex is h and k. H is the x value of the vertex, and I see h right here. So if you have your equation in vertex form, you can figure out the value that would result in the maximum just by looking here at h. So the big idea here is, yeah, there are 3 forms of quadratics, and there are parts of each of the different forms that can be used to help us with problems in real life. If we want to find out what is the initial value, standard form would be best. If we want to find out the maximum or minimum, vertex form would be best. If we want to find out what is the input, what number should we put in to give us the maximum or minimum, still vertex form. That would be h. And finally, if we want to find the zeros, if we want to find a value of x where the answer would be, the final value would be 0, then factored form would be best, because r and s would give us those values. But we do need the equation to start with, and that will help us get to the answer in all of these different ways. Let's take a look at an example for that. So on Planet Fitness, the height of a sports ball that is thrown in the air at 48 meters per second can be described by this equation. M, you see M here? That is the ball's height. So if I want to know how high the ball is after it's thrown, I can just calculate this. M is the ball's height in meters. T is the amount of time in seconds after the ball was thrown. So using these ideas, I can figure out exactly what the ball's height is. If I want to know how high is the ball 2 seconds after it's thrown, I can just plug in 2 into t, and then I can evaluate this, and that will tell me what the value of m is, and m is the height. What we can do now that we have an equation, we can use this to determine all sorts of stuff. We can use it to determine the maximum height of the ball. We can use it to determine the time when the ball is a specific height above the ground. We can use it to determine the time when the ball would hit the ground. All sorts of really, really fun stuff. So I'm going to take this equation like you just saw, and I'm going to use it to answer all of these questions. The first one is the maximum height of the object. Now, part of this unit was creating graphs out of quadratic equations, and we want to make sure we're connecting our ideas from the equation to the graph. Let's work with this equation a little bit first. First of all, what form do you think this is in? Take a second to think about that. Which of the three forms is this in? This is actually in standard form. It doesn't look like it because usually the squared term is in front. So I'm actually going to fix that. Okay, I'm going to rearrange this and move this squared term in front so it looks like this. This is positive 48t, so it still remains positive. And this is now in front. So we can see it's in standard form. What I can do here is I can factor it. I can divide both of these by the greatest common factor. And that factor is negative 16t. 48 is 16 times 3. Both of these terms have at least one t in them. This one actually has 2, and this one has just 1. And because the first term is negative, I always like my first term to be positive, so I will factor out the negative. And so how do we factor? We divide both of them by the greatest common factor, and this is what we end up with. Notice the greatest common factor is in front, and this negative 16t squared divided by negative 16t is just t. And 48t divided by negative 16t is negative 3. Remember, when we divide, things will cancel out, right? So what's going to cancel out here is t. And what's going to cancel out here, one of these t's is going to cancel out with one of these. And what we'll be left with is just negative 16 divided by negative 16 is 1 times t. And over here, 48 divided by negative 16 is negative 3. So now that it's factored, okay, and hopefully you understood how I factored out the greatest common factor, what can I do with this? This is factored form. This is factored form, but it doesn't look like it. So I'm going to rewrite it a little bit. And notice what I'm going to do. I'm going to take this t, and I'm going to rewrite it as t minus 0. Now, that doesn't actually change anything. If you add or subtract 0, it doesn't do anything. But I've just done it so it looks a little bit more familiar. Remember, this was standard form, but it didn't look like it until we moved this negative 16t squared in front. I like it when it actually looks like the form, and that's just for me. So I put this minus 0 in here just to make it look like factored form. Now that I have it in factored form, it's really easy to graph it, right? I know that one of the roots, one of the x-intercepts, if this is the x-axis, is 0. And so I will place a point right there at 0. And one of the other x-intercepts is 3, positive 3. This is t minus 3, which means that the intercept is positive 3. It's always the opposite of whatever this sign is. And so I'll take that and I'll put it at 3. And finally, to draw this parabola, I have to know, is it shaped like a U or is it upside down? And to know that, I just need to look at the A value. Because the A value is negative, what do we do when we're feeling negative? Do we smile like this? Or do we frown like this? For feeling negative, of course, we frown. We make a sad face with our mouth. And that's how I know that this parabola is shaped like this. It has a x-intercept at 0 and 3, and it opens downwards. Notice I haven't written anything on my y-axis. I'm not sure how high this goes. I've just drawn a parabola, and I'll figure out what the vertex is later. For now, it's just a rough sketch. Although my x-intercepts are correct. Now, the last thing I can do here, if I want to find out what the vertex is, remember that what I can do is take the number that's right in the middle And I can see here that this number is 1.5. But if I want to verify that that's actually true, I can take the mean or the average of the two zeros. So 0 plus 3 is 3, and 3 divided by 2 is 1.5. So yes, I was correct that the axis of symmetry is x equals 1.5. Right? This is a line, an axis, where the parabola is the same on the left as it is on the right. The axis of symmetry is super helpful because that is the same as the x value of the vertex. And we even see the axis of symmetry going right through the vertex. What this means is I can take that number and I can plug it into my equation. So negative 16 times 1.5 minus 0 times 1.5 minus 3. That's what I've got here. And that equals 36. If I actually evaluate it all, it equals 36. And that's how I know that the vertex is going to be right here, and that is going to be at 36 units on the y-axis. Okay? So this is a really good graph of my parabola. And this is remember, this is supposed to describe the height of a ball in meters t seconds after it was thrown. So when I throw the ball up like this, this is the maximum height that the ball will get to. It gets as high as 36 meters above the ground. And then it falls all the way back down to the earth. And when does that happen? Well, let's figure it out. The maximum height of the ball, so that's the answer to A, is 36 meters. And it happens 1.5 seconds after the ball is thrown. So just one more time from the start here. What I did was I took my equation and I turned it into factored form. I used the factored form to plot out the x-intercepts and the direction the parabola was opening. And then I used the two x-intercepts to find the axis of symmetry, and that helped me find the maximum. It helped me find the coordinates of the vertex, and I plotted that down. So that would tell me that the maximum height is 36 meters. What about for question B? The time when the object is 32 meters above the ground. Well, okay, 32 meters above the ground is the object's height. And that is using the variable m. So I know that the value of m is 32 for question B. When is that object 32 meters above the ground? So 32 would be like about here. And I can see that when does that happen? What time, right? What is the time that that happens? It looks like 1 second. It also looks like 2 seconds. So both of these times, the object is 32 meters above the ground. The first time it's going up, and then it comes back down. The ball comes back down, and it's at 32 meters above in the air 2 times, at 1 second and 2 seconds. But let's actually figure it out, because I know that my parabola is really good, but yours might not be so exact. Let's see if we can calculate this time right here. So I'll say 32 is m, and m is equal to all of this, right? Negative 16t squared plus 48t. So all I've done is I've replaced m with the height that I know the ball is going to be, 32. And now I'm going to find out what is the value of t. And this is really kind of the lesson for today. All of the other stuff is stuff that you kind of know how to do already a little bit. But today we're going to learn how to solve a little bit of a harder question. So what I'll do is I'll make one side equal 0. So I'll subtract 32 from this side, and that gives me 0 on this side. Now, of course, I have to do the same thing to the other side. So I subtract 32, and I can combine these. Well, actually, I can't because none of them are like terms. So it just becomes this, and it looks like standard form. What I'll do now is I'll try and factor this. So step 1 was input the variable that I know. Step 2 is make one side equal 0. Step 3 is factor what's on the other side. So I'll divide all of them by negative 16 because all of these are multiples of 16. And I end up with t squared minus 3t plus 2. And of course, my greatest common factor needs to go in front. Now I can continue to factor. What would this factor into? What are the factors of 2 that add up to negative 3? Negative 2 and negative 1. Negative 2 times negative 1 is 2, and negative 2 plus negative 1 is negative 3. So when I add them together, of course, I get negative 3. And that's how I know that this part right here will factor into this part right here. So I've turned it from standard form into factored form. That was step 3. Why would I do that? How does this actually help me? So what values of t would make this equation true? 0 is equal to all of this. How could I make this equal 0? Well, remember that in factored form, to find the zeros, it's just r and s. In fact, I can never make this factor equal 0, right? There's no value of t that will ever change negative 16. But this factor right here, if t is 2, then this is 2 minus 2, which is 0. And if t is 1, then this part is 1 minus 1, which is still 0. And we know that when we multiply all three of these together, if one of them is equal to 0, then multiplying them will always equal 0. So these are the values of t that would make this equation true. So t could either equal 1 or it could equal 2. And that would make this equal 0. And that would also make this equal 32. Let's see if that's actually true. The number 1, I'm going to place it right here at 1 when t is 1. And when t is 2, which would be right here, both of these are equal to 32. The parabola is, the y values are equal to 32. So the ball is 32 meters above the ground 1 second after it's thrown and 2 seconds after it's thrown. Once when it's going up and once where it's coming down. Finally, C is asking us, what time does the object hit the ground? Now, hit the ground, when the object is on the ground, that means its height is what? It is 0 meters. The ball's height is equal to 0 when it's on the ground. Okay, so if m is 0, I'll just use the same thing that I did last time, right? I'll make one side equal 0, and then I'll factor the other side. Now, I already know that this equation will factor into negative 16 times t minus 3. And if m is equal to 0, well, how can I get these two factors to be 0? It's pretty easy, right? This is, if t is 0, then this is negative 16 times 0 times something, which would always equal 0. So if t is 0, this would make everything equal 0. And if t is 3, this would be 3 minus 3, which is 0. So negative 16 times 3 times 0 is also 0. And notice on my parabola, when is the ball on the ground? At 0 and at 3. Now this question, remember, you have to be very careful. You have to look at the question, see what it's really asking you. This is why literacy is also important, right? I'm asking, when does the object hit the ground? Over here, it doesn't hit the ground, even though that when t is equal to 0, the object is on the ground. When t is 3, the object is on the ground. But 0 is when the ball was thrown. So it was thrown up, and then it hit the ground only at 3 seconds. So let me summarize here. Every situation that is related quadratically can be written in these three forms: factored form, vertex form, and standard form. And we have learned how to move between these three forms. We know how to go from factored to standard, from vertex to standard, and we also know how to go from standard to factored. And using any one of these three forms, we can graph our parabola. When we're given a word problem or an application of quadratics from real life, and we can figure out if we have the equation and we know what one of the variables' values are, we can solve for the other variables. Usually it's x and y. So if we're given y, we know how to solve for x now, thanks to our work throughout all of this unit. And knowing that will help you progress through these word problems. If you want to solve a quadratic, and remember, solving means find the value of x that makes the equation true. So if I give you a value for y and I give you the equation, can you find out what x is? This is how you do it. You move all of the terms to one side. So you make one side equal 0. You factor the side that has the terms on it, right? So you go from standard form into factored form. And then the x-intercepts, or the roots or the zeros, the values of r and s of that factored expression, those are the solutions to the quadratic. That is how you solve it. Let's do an example here. Liasha wants to grow plants in her rectangular garden. The planting area is 2 meters long and 6 meters wide. And okay, so I'm just going to start with a diagram right away. So my diagram is going to be, here's the planting area. Remember, it's 6 meters wide and it's 2 meters long. And she wants to build a stone border of uniform width. Uniform means it's the same. So she wants a border that is the same width all around. So sort of like this, right? Where whatever this distance is, and I'm not sure how wide she wants it to be, this distance will be the same as this distance, will be the same as both of these distances as well. So it's the same width all around. She wants the total area of the planting area and the border. It must not exceed 32 square meters. So if she wants that to be true, what is the greatest possible width of this border? Well, this is a rectangle, right? It's a rectangular garden and it's a rectangular border as well. So the total area will be length times width. Okay, now what is the length and width of the total area here? The length is 2. What's this distance? Well, that is x. That's the same as this, right? So this is 2 plus x plus x. And the total width is 6. And what's this distance and this distance here? Well, that's also x. 6 plus x plus x. So let's replace the variables with the values that we know them to be. The area is 32. The length is 2 plus x plus x. And the width is 6 plus x plus x. Now I'm going to start to simplify this a little bit, okay? I'm going to make it a little bit simpler for me to do. So here I have, what is 2 plus x plus x? Well, I have 2 x's, so that's x plus x is 2x, plus the 2. Notice I always like to put the variable in front. And this is 6 plus x plus x. So again, I have 2 x's plus 6. This is still the length, 2x plus 2, x, x, and 2. And this is another way to write the width, right? X plus 6, 2x plus 6. Okay, what can I do with this? Now I've come up with an equation, and this is clearly a quadratic equation, and I'm going to use the steps that I explained earlier to solve this. So first, I'm going to simplify everything here by expanding. Okay, and we know how to expand binomials, don't we? 2x times 2x is 4x squared. 2x times 6 is 12x. 2x times 2x is 4x. sorry, 2 times 2x is 4x, and 2 times 6 is 12. And we just have to add these together, and all of them should equal 32. Now let's combine our like terms, right? We have to simplify this. 12x plus 4x is 16x, and there's no other x squareds or numbers on the right side of the equal sign, so this is what my equation simplifies to. Now what I'm going to do is move this 32. Remember, I want one side to be 0, so I'm going to get rid of 32 on this side. I'm going to subtract 32 to solve this equation. And I do that by making one side 0. So that will cancel it out here, and I'll be left with nothing on this side. But I can't just subtract one side. Whatever I do to one side, I have to do to the other. So I'll subtract 32 on this side as well. And what I end up with is 0, like I planned, equals 4x squared plus 16x. 12 minus 32 is negative 20. Now that I've done step 1 of my problem-solving steps, which is to make one side equal 0, now I need to factor this expression that I've got here, right? I have to factor this as much as I can, and I can see that 4, 16, and 20 are all multiples of 4. So I'll divide all of them by 4, and this is what I get. 4x squared divided by 4 is x squared. 16 divided by 4 is 4, and 20 divided by 4 is 5. And of course, I can't forget that I need to put that number that I divided out, I need to put it in front, because that's what I have factored. Now, am I done factoring? Absolutely not. I need to take this expression and factor it using the skills that I did learn in the previous lesson. So I'll take negative 5 and I'll look for two factors of negative 5 that add up to positive 4. And that is positive 5 times negative 1 gives us negative 5, and positive 5 plus negative 1 gives us 4. And so these are my two factors, and therefore this expression right here factors into x plus 5 times x minus 1. Now that I have it in factored form, I'm done my second step of solving a quadratics, because this equation is much easier to solve than this equation up here. And it's easier to solve because I have it in factored form. I just need to know what values of x will make either of these factors equal 0. So let's take a look at that right here. So these are the two factors. I want to know what makes them equal 0. Let's see, I'm going to say x plus 5. I want this to equal 0. So I'm going to move the 5 over to the other side. I'm going to subtract 5 on both sides. And I'll do the same thing on this side in a minute. Okay, so first let's work on this equation. So I'll subtract 5 from both sides. That'll cancel it out. And I'll be left with just x on this side and negative 5 on this side. And that's true, right? Negative 5 plus 5 is equal to 0. And 4 times 0 times whatever this is going to equal 0. So this is one of my solutions. What about this? X minus 1. What value of x could I put in here such that when I subtract 1, I'll get 0? What number minus 1 gives me 0? It's super easy to know that, right? You would just say 1 minus 1. That's 0. And of course, if we do our algebra steps, that'll confirm it. If I say x minus 1 gives me 0 and I add 1 to both sides, I'm left with just x on this side, and 0 plus 1 is 1 on this side. So both of these will make this equation equal 0. However, this is a real life question, right? What value of x, what is the width of this border to get me an area of 32 meters squared? Well, the width can't be a negative number. That doesn't make sense. So I have to say that I'm going to ignore this solution. My width will probably be 1 meter wide. Okay, that's the width of the border, the stone border. And I'm going to confirm this with a graph. Okay, so in this graph, I've put this equation here, 4x squared plus 16x plus 12. And then I've also put the number 32, y equals 32. And when does this actually equal 32? When does my parabola have the same y value as this line of 32? I can see here that my solutions are correct. Notice that this is a standard form of a quadratic, and it has made a parabola. And I can see that this parabola equals 32, that's my y value of 32, when x is -5 and when x is +1. So I can confirm that when the width is 1 meter, the area of the garden is 32 square meters. And that is step 3. Step 1 was make one side equal 0. Step 2 was factor the other side. Step 3 is figure out what values of x make the entire equation equal 0, or what values of x make each factor equal 0. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.